Our next speaker is James Russell. James Russell is from the University of Auckland in New Zealand, coming from our beautiful region of the South Pacific. Kia ora, James.
Kia ora. Kia ora tātou, everyone. About 18 months ago, Annual Reviews invited me to write a review on the topic of island biodiversity in the Anthropocene. And it was a really fun challenge, and I reached out to Christoph Käufer because of his complementary skills in plant biology and some of his different takes on some of these. In fact, it's been pointed out, we seem an interesting pairing to write a review on this topic, but we enjoyed debating and changing some of our worldviews on invasive species and novel ecosystems, for example, with one another. When putting these slides together, I actually was going through my photos to find a nice little island to be a banner here, and I just realized yesterday that actually this island is Leeward Island off the coast of Antipodes Island in the New Zealand subantarctic, and until a few years ago it had literally never been touched by humans. As we undertook mouse eradication on the nearby main island, we had a helicopter in this group for the first time in history, and we had to land a helicopter on that island just to check that by some rare chance a skua bird hadn't taken a mouse and dropped it alive on this island and it had invaded. So there are still islands in the world that have never been touched by humans in any way. So just an outline for what I'm going to talk about today from this review paper. The first thing Christoph and I asked ourselves is, well, what kind of working definition of the Anthropocene are we going to use? And then I'm going to talk about the next question, which was, well, what actually is island biodiversity in the context that we want to consider it? And we realized that we really couldn't talk about island biodiversity today if we didn't consider island biodiversity in its formation before humans impacted islands. So I'll speak about that. I'll then take you through our different categorizations of human impact on islands through first contact to what we called modern history since 1500 through to the contemporary era today in the 21st century. And then I'll get to some exciting new data we compiled from other studies and synthesized in a new way on some of the drivers, the current threats to island biodiversity and the emerging patterns. And then I'll finish by some of Christoph and I's ideas on protection and restoration and cultural landscapes and novel ecosystems and how really islands can adapt to the future. So some damning statistics that we'll all be familiar with. 78% of the planet's surface is today considered anthropogenic biomes, and it's been predicted that up to 58% of vertebrate species might go extinct in the 21st century. So it's certainly clear to all of us here that the scale of the effects of humans on physical, chemical, and biological processes have led scientists to introduce this concept of the Anthropocene, which has still not been formally adopted by the geological societies, but they're moving towards that. There is still some debate about when it officially started. Some people like to go back to the Industrial Revolution, if not earlier. Some people think just the 21st century, but the general agreement is that post-World War II period, most commonly the mid-20th century, particularly the advent of nuclear weaponry and the radiation marks that has left in our atmosphere. And then we also just wanted to clarify what type of islands we'd be working on. So we focused on islands surrounded by water, and more specifically those in oceans and seas. We didn't want to refer to them as oceanic islands because that it refers specifically to those volcanic islands that have never been connected to any continent. So in a broad sense, we just refer to these as marine islands, but we're not considering freshwater islands or other habitat type islands that sometimes get invoked in consideration of island biodiversity. So to that end, the Global Island Database identifies 175,000 islands greater than 0.1 of a kilometre squared, and just short of 18,000 of those are larger than 1 kilometre squared. And as we know, they make up just over 5% of the planet's land area. 1/4 of the world's countries are islands or archipelagos, and more than 2/3 of the planet's countries include islands in some form or another. And just considering data compiled from small island developing states, islands are home to at least 50 million people. So a large number of people are interacting with islands on a daily basis as part of their livelihoods. We really wanted to break down biodiversity because this has downstream ramifications for when we talk about different threats and their impacts, and particularly around introduced species, following on from the plenary that Tim Blackburn gave when we look at alien species richness. And we wanted to emphasize that species is a really important part of biodiversity. You can see it there, that when we talk about species, there is at the bottom there just the pure species richness element and particularly the unique endemic island elements, and we can decompose that to estimates of alpha, beta and gamma diversity. But also when we're considering the species on islands or in biodiversity in general, we have to consider the abundances of those species, where we see such things as density compensation on islands. We have to consider the uniqueness, the phylogenetic uniqueness of those species, where we might see radiations and living fossils occurring more often on islands. Even prior to that, genetics is a really important component of that, and we've already seen some good talks about that at the conference so far, where we can look at ways of measuring genetic variation at the individual level, at the subpopulation level, and in the total population level across archipelagos. And there are lots of good genetic tools and methods to do that. One suite of statistics that's quite powerful is just the F statistics that are used. But even then, when we're considering biodiversity, it's just got so many components when we're trying to metricize it. And so other ways to look at it might be interactions and how unique those are on islands and the pairings and couplings of those. And my colleague Christopher Kaiser-Bumber will be giving a talk about networks on islands later on Thursday in the Seabird session. And then we're starting to see some emerging work around island syndromes. There's been some good work on that on plants, but Casey Burns has just published a great book with Cambridge University Press on plant syndromes, island syndromes in plants. So, and it's also been described in reptiles as well, so another important component of biodiversity. And finally, we have to look at the role habitat diversity plays in driving biological diversity. So those components include whether you're on a volcanic island, such as the Hawaiian archipelago that Rosie Gillespie's talking about and done so much work on, the atolls around the world, or even those continental islands off adjacent coastlines. I don't want to dwell on island biodiversity formation before humans, because it's well known to all of us from our undergraduate studies. Although these stages don't necessarily occur consecutively in this order, we see classical things such as historical contingency creating unique circumstances, community assembly occurring through things such as taxon cycles and assembly rules, and eventually evolution on islands through processes such as anagenesis and cladogenesis. So we have an illustration in the paper which just shows how sometimes species aren't even able to disperse to islands from a nearby continent. Sometimes they can disperse, but they're not able to establish. Some of them can establish, but then bad luck, that volcano or that storm may have an impact on you. Even then, the assembly processes can kick in and you might not be a winner in those sweepstakes. Or finally, you might push through and encounter some form of evolution to create speciation and diversification in island biodiversity. So those were all the standard processes we know were occurring before humans arrived. But then we had first contact, which the dates of that vary greatly across islands around the world, so we don't put a particular date on that, but we note that when humans on islands arrived, they typically ate their way down trophic levels, starting at the megafauna and working their way down. Insular species were more vulnerable than continental ones because of those island syndromes and the lack of refugia on small islands. By simply being a smaller land area, there were fewer places for species to hide. We know from the Pacific that 20% of the avifauna, or at least 1,000 species, went extinct following first contact. Following that, though, the modern era does have a reasonably clear date of about 1500, corresponding with the age of discovery when Europeans spread out from Europe. So in modern history, we know European culture came to dominate much of the world due to that extensive overseas exploration and the rediscovery of remote islands that already had indigenous people. Whereas during the initial indigenous people phases, they tended to be primary economies just based on extracting resources for local use. The economy shifted now to exploiting the natural resources, but more towards a secondary economy, focusing on manufactured goods which could be exported back to continental homelands. During this period, since 1500, 90% of bird extinctions that have occurred in the world have been on islands. And we also saw that population size and cultural diversity of indigenous people also declined dramatically at the same time as biodiversity began to decline. So in the contemporary era today, with rapid international transit, globalization, and the diversity of vectors and pathways for introducing new species and diseases have all increased, and we're seeing the types of introduced species changing. The historical biogeographic barriers that delineated the world, in particular islands from continents, have broken down. We're seeing diversification to tertiary economies towards tourism and diminishment of colonial Western European powers promoting independence for many islands. So we compiled 2 data sets. We had Maxwell et al. In Nature published a summary of all threats to IUCN red-listed species in total, whether they be on continents or islands, and not long after that, Leclerc et al. Published a list just for species on islands. And so what we found was that of the 8,000 or so IUCN red-listed threatened species, half of those, just over 4,000, occurred wholly on islands. So for threatened species on the IUCN red list, half of them are on islands. So that's kind of our baseline here. And what I want you to see is that for any given threat, we see that for, say, overexploitation, if you're one of the 6,000 species that suffers from exploitation, only 2,000 of them, or 38%, are found on islands. So less than you'd expect from the expectation. What jumps out here is that, in fact, the only threat that is more prevalent on islands for island species than continental species is invasions and disease, where if you're a species on the IUCN Red List vulnerable to invasion and disease, you're much more likely to also be on an island. But I would note here, although it's the higher percentage, on islands themselves, more species are still vulnerable to overexploitation and agricultural activity. So the takeaway message here is that although invasions and disease have caused the most extinctions in the past, and we think kind of are able to deliver the coup de grace of making species go extinct through the way predators in particular can hunt out the very last individuals, overexploitation and agricultural are still the major threat to species on islands, but disproportionately invasive species are more likely to impact island species. We tackled the species richness. I won't spend too much time on this, but we really wanted to get to the bottom of this idea that it's not just about species richness alone, because we end up in these kind of spurious debates about whether introduced species are improving species diversity or declining it in species richness. And it's really a question of scale. But we see here an example where we have an atoll, an archipelago with 26 native species. You introduce 5 species, and it's the same 5 species turn up in different numbers to different islands. You lose 5 unique species that were island endemics. So at the end of the day, you might say, well, you started with 26 species in the archipelago and you finished with 26 species, so species richness has stayed the same and nothing bad has come of these introductions. But in reality, you've lost 5 island endemics, and this calculation of gamma diversity is really scale dependent, because then if we extrapolate it globally, we've lost 5 species from the world, but those 5 introduced species were already found in other places of the world. So once again, that clear story of the homogeneity of the world's fauna and flora through introductions of species. So we finally finished by talking about adaptation, and we link back to those 4 islands because they each provide a different example. Islands, one there is a good example of protection, where you have undisturbed natural habitat which remains only in small pockets, but you can protect that and undertake conservation, whereas on Island 4, it might be a good candidate for restoration, which has been particularly prevalent on small uninhabited offshore islands, where we can do eradications, replantings, and reintroductions of species. Island 2 might be a novel ecosystem landscape, where as a result of former land use, novel ecosystems have developed, mixed species compositions of native and non-native species occurring together. And we do really emphasize here that decisions around management of novel ecosystems include a really strong values component, where there's a lot of ongoing debate I think a lot of us are aware of. Another example would have been Island 3 in that previous slide, which was a cultural landscape. Native biodiversity persists across it, but it's an island landscape that's used by humans as part of their livelihoods. So subtle changes in management and behaviour here can promote biodiversity in these landscapes, but we have to build on local knowledge, culture, and sovereignty to really enable this on islands. We also summarised protected areas on islands, and we got some really good data out of the Protected Planet data on protected areas around the world. So we see that on average, 23.5% of the world's islands are in some form of protected area status, although that doesn't necessarily mean that protected status is effective in management. But that's a really good statistic, I think, that 23.5% of the world's islands are in protected area status. And we can see some clear trends. Those first 6 islands there are all uninhabited islands, and another bias we see is the brown islands are island nations, territories or dependencies owned by continents, whereas the blue islands are all our small island developing states. So we see a bit of a bias that the small island developing states are a bit under-prescribed for protective areas. The other point I'd just make is the number of protected areas alone isn't necessarily a good correlate. You can have very high numbers of protected areas, but then be below the average. So it's whether these are small protected areas and there's lots of them, or large protected areas in smaller numbers. But some statistics there for all the island groups around the world. So in conclusion, a couple of slides of conclusions because there's some management to follow. Islands can serve as model systems for biodiversity conservation in the Anthropocene, and they teach the importance of holistic approaches. Biodiversity takes many forms, and it is far more than species richness alone. The biogeographic boundaries of islands have been removed by globalization, and we've also seen a resurgence of indigeneity and a return to independence, especially for small island developing states. Invasive species have been the major driver of extinctions and of current threat status on islands disproportionately. When we talk about management, we think although the impacts of biological invasions have consistently been the major threat on island ecological communities, emerging threats such as human-induced climate change will become more pronounced, although today, as the major threat to IUCN red-listed species, they're still quite small. Protection and restoration of ever-diminishing natural areas will remain critical, but biodiversity can also be enhanced in cultural landscapes that combine natural and human values and activities. And on many islands, novel ecosystems of mixed native and non-native species will need to be accepted and managed in perpetuity. So I just want to leave you with our summary conclusion from the paper, and I'll be happy to take any questions. Thank you.
Thank you, James. It's working? Oh. Thank you very much for your interesting talk, and we have a couple of minutes for questions.
I think there is two very different kinds of situations where you had a long history of indigenous people in islands changing gradually and adapting to the environment. And then we have, for instance, many islands where we have 500 years of history of human impact that was very rapid, changing dramatically. What is your opinion in how we should manage or think in long-term management of invasive species in these two kinds of situations?
I think for those islands, we can just look at them through these three different lenses of are they still what we consider pristine and native, or I think for those islands that have a long human presence, we're really moving into those cultural landscapes where it's very difficult, it's difficult to agree on what is native or even have the scientific tools using genetic or paleological methods to determine what was historically native. So we're really looking at managing the human-nature relationship on those islands. And then I think probably the novel ecosystem component then comes on more on some of these more recently colonized islands where we just have a clear mix of native and non-native habitats, but they're really merged together and they're really difficult to disentangle. So I think the framework there can work, but we just have to be clear which of those types of habitats we're working on and really getting involved in the value discussions around those as much as the scientific evidence for what's native and what's non-native.
Thank you very much for a really fascinating talk, and your final point about managing this human and biodiversity relationship going forward is incredibly ambitious. And I wondered if you have thoughts on what are the major knowledge gaps, because in some senses it's going to be a game to play, and we don't yet know all of the rules. So what are the major gaps in understanding that are going to allow us to play that game most effectively?
I call myself a conservation biologist because I was trained classically in biology and statistics, but as I moved forward trying to achieve conservation aims, which for me, for the most part, is rat eradications on islands, I realized most of the science gaps we had were social science. And so very much I've moved myself into a social science space where there's some fascinating social science and political science questions about, which we know well from climate change, why despite all of the technical, biological, chemical, physical evidence do we continue to persist in poor choices? And those are fascinating social science and political science questions. So I really urge all conservation biologists or biologists in general that want to see this meaningful change to either partner with really good, trustworthy social scientists and political scientists you have good working relationships with, or retrain yourself, even though you have a particular tool set. Mine is mark recapture of rats on islands. It's not useful for a lot of the gains we want to make on rat eradication on inhabited islands, for example. And we're very lucky in New Zealand that we've really moved forward with our relationship with the indigenous people as a legacy of the treaty we signed. And that's a really challenging issue because you have to work over a lot of social injustice that's occurred, and the indigenous people quite often tie the environmental injustice with the social injustice together, and if you work towards restorative justice on the social issues, you can decouple the environmental and the social justice issues and make progress for the environment.
So we don't have more time for questions, but maybe at the end we can talk with the speakers.